Welcome back to 3.1 pre-calculus. We're going to do a couple of these graphs. I'm not going to do the first graph because there's just one transformation in number 5. If you want to see that one, you can look at the bottom of the notes that I provided. Same thing for number 6. So let's look. Number 5, that would be a horizontal shift to the left 5. 6 would be a vertical shift down 2. I'm going to start with number 7 because it at least has a couple of transformations. They're both vertical transformations, but let's start here. All right, and to do these, we're just going to come up with a graph, or a table, and we're going to put in our parent function. So remember, we had the point for 3 to the x. If x is -1, 3 to the -1 would be 1/3. When x is 0, 3 to the 0 is 1. When it's 1, we got 3. When it's 2, 3 squared would be 9. So there gives us a couple of points. I'm not going to go too crazy with the fraction ones because, well, those are really hard to graph anyway. All right, my transformations for this one is a vertical, compression by 1/2, and then a vertical shift up 1. So we're just messing with the y values. So for our y values here, we're going to multiply them by 1/2 and then add 1 to them. So my new y's are going to be 1/2 times that y value plus 1. So -1/2, 1/2 times -1 would be -1/2 plus 1, that's going to become +1/2. 0 times 1/2 would be 0 plus 1 would be 1. I say this, and yet I am doing these to my x's, and I want to be doing them to my y's. You're probably screaming at me at home saying, what are you doing, Miss Harris? To my y's, because this is our vertical transformations, we're going to be multiplying the y's by 1/2 and adding 1. Let's try that again. So again, this first one's going to be really weird. So 1/2 times 1/3 would be 1/6 plus 1. 1/6 plus 1 would be 7/6. 1 times 1/2 would be 1/2 plus 1. That's going to be 3/2 or 1.5. 3 times 1/2 is 3/2 plus 1 would be 5/2 or 2.5. 9 times 1/2 would be 9/2 plus 1 would be 11/2 or 5.5. So lots of yummy fraction math here. So when we're at -1, my y value is just bigger than 1 at 7/6. Again, it's hard to graph these fractions. When we're at 0, my new y is 3/2, which is 1.5. So 0, and then we're at 1.5, which I can't quite get in there. And when we're at 1, we're at 2.5. So 2.5 is up here. When we're at 2, we're up at 5.5. So 2, 3, 4, 5.5 is kind of up here. So our function is looking something like that. Hopefully you can get a little bit more precise than my finger is getting, but it doesn't have to be too big. Big change here is our asymptote. What happened to our asymptote? It shifted up 1 with that vertical shift. So my asymptote, if I can try to get it underneath the graph, is right there at y equals 1. My intercept, we said, is at 0, 1.5 or 0, 3/2. Domain is going to be all real numbers, just like before. Range is going to be shifted up 1 with that vertical shift. So instead of going from 0 to infinity, it's going to go from 1 to infinity. As x goes to positive infinity, our y's go up to positive infinity. And as x goes to negative infinity, those y's are going to go to, I don't know why I'm writing negative. Let me give up on this. Our y's are going to go to positive 1 instead of 0 because it was shifted up 1. All right, let's take a look at the next one. It has a couple of transformations going on. Is this one going to be an increasing or decreasing graph? Increasing. It's 3/2, which is a fraction, but that fraction is bigger than 1. Press this button again. All right, so our base is 3/2. So if it's -1, 0, 1, 2, I'm just going to do a couple. So 3/2 to the -1 power just flips that fraction, makes it 2/3. 3/2 to the 0 power is 1. 3 halves to the first power is 3 halves. And to the second power would be 3 squared over 2 squared. So our two different transformations we have going on here. So up here in the exponent, I got a -4. So to all of my x's, I'm going to be adding 4. I'm going to do the opposite of what it says. And then I've got a vertical shift down 5. So to all of these y's, I'm going to be subtracting 5. So for this first x, -1 plus 4 would be 3. 0 plus 4 is 4. 4 plus 1 is 5. 4 plus 2 is 6. Over here, this is going to be really hard. So 2/3 minus 5, well, that would be like 5 minus 2/3. So -4 1/3. 1 minus 5, that one's nice and neat, -4. -5 plus 1 1/2, so that would be -3.5. This is 2 1/4. 9/4 would be 2 1/4. So 2 1/4 minus 5, that would be -3.75, if I'm not mistaken. All right, so those are our new points that we're going to graph. We have a point at 3, -4. So over 3, down 1, 2, 3, 4, and a little bit would be right in here somewhere. And then we got 4, -4. That's right at that intersection, if I could draw it. And then 5, -3 1/2. And then 6, -3.75. There's something funky with that. Oh, this would be, sorry, -2.75, because it was -2 1/4. So -2 75.75 would be about here. So here is my graph, getting its exponential curve going on right there. Where's that asymptote going to end up at? It's going to be shifted down 5. So if I go down 5, that's where my asymptote needs to be. And this guy is going to hug it as it gets close to it. My intercept for this one, well, we didn't exactly figure that one out. So let's go ahead and put that one in, because we didn't, once we got it shifted over, we didn't find it. So if we plug in 0 for x, we have 3 halves to the -4. Whew. Let's see, that's going to flip the fraction. So that would be 2/3 to the 4th power. And then we're going to raise each number to the 4th. So 2 to the 4th would be 16. 3 to the 4th would be 81. So 16, 81, 0. Oh, I don't want that to go down. Why did it go down? 0. And then 16, 81. Don't worry, it won't be this hard on your quiz, surely. There we go. Our domain is going to be the same thing, so -infinity to +infinity. Our range this time, because we got shifted down 5, we're going to go from -5, not including it, to infinity. As x goes to +infinity, our y's are going to +infinity. And as x's are going to -infinity, our y's are going to go hug that x-axis and go to -5. All right, if you want to see another example, feel free to scroll down on your notes. You can go check out 9 and 6 and 5. They're all the way at the bottom of the notes that I posted for you. And basically that's all we're doing today, is just reviewing these exponential graphs, reviewing transformations, and you're going to be like matching them up on Wednesday and Thursday. Tomorrow we're going to get into logarithmic graphs and remember what those look like. You guys have a good night.